Hey everybody! Hey, we're gonna go and get started pretty soon. If you want to take your pizza to your seat, grab your pizza, throw your pizza away, drink your beer, bring your beer, come on with it. We have a very exciting talk for you guys. I'm assuming. Where'd the guy go?
Has anyone seen the speaker?
Oh my god. We lost the speaker.
There he is. All right.
Search party for Randall. Search party. Search party. All right, we have Randall here tonight. He came all the way in from San Francisco to talk shit about web tokens, which I know a lot about, and hopefully you can expand my mind to learning something different. Welcome everybody. Thank you Code Talent for the beer. Thank you Google for the pizza and Denver Pizza Company. That's very awesome. Anyways, we'll just give it to this guy. Should be out of here by 8 o'clock. And maybe Black Shirt Brewery, maybe Barrels after, but we might be hanging out after, so take it away. Oh, and I think we have Brooks over here on Twitch and whatnot. Are we live, right?
Yeah, we're streaming this live on Twitch TV.
Streaming live, and we need to get this up here.
How do we, I think I went to sleep or whatever.
Is it just plugged in?
Yeah, you want me to plug it in?
Cool, thank you guys. Enjoy your
Are
set.
you plugged in?
Turn this off, back off.
Yeah, let's do this. Pull it out. Put it in the side. Probably just needs to read. It was working for a second there, right? Oh, yeah. That's totally good.
I'm feeling positive about this. All right, guys, what's up? How's it going? It should be super fucking fun, so get ready. Before I start, though, I just want to mention one thing. I brought a bunch of free t-shirts for my company, in case you want them. They're on the table in the far back right corner of this, so whenever this is over, you can go grab one. There's quite a few, so help yourself. And also, I'm like a super casual presenter, so if you have any questions as we're going, like just let me know. Let me know, raise your hand, we'll deal with it. The best questions get a book. So if you're interested in OAuth 2 or like any sort of like authentication stuff, I'm like super passionate about this stuff, I work on it all the time. If you are into it, I have this book, my friend actually wrote it, so he gave me some free copies to hand out. Anyways, okay, so let's get right into this. Now, hold on, I gotta fix this, one sec. Full screen. Okay, so here's the thing. My doctor actually told me that like if you get upset or like feel emotions, you shouldn't just bottle them up. So what you can do is like, I know a lot of you, just from talking to people before this started, use JWTs, are familiar with JWTs, know a lot about JWTs, and are like, why is this talk like shitting all over them, basically? And so if you get upset, you can ask the question. You can also just tweet hate at me. That's also totally fine to do. So this is my personal account, and that's my company account. Feel free, I literally don't mind. I'll go back and retweet them later, it'll be funny. So a little bit about me. My name is Randall. Thanks for the awesome intro. But basically, I run developer advocacy at this company called Okta. What I do is I build open source security software in Python, Node, and Go. So I spend a lot of my time researching authentication protocols, building open source libraries to implement these things across different languages, and then giving tech talks to sort of like educate people about best practices, what's awesome, what sucks, and just generally try to like make developers happy. I've been doing Python, Node, and Go software like forever. Started programming when I was a little kid, so this is like sort of natural for me. So, before we get into it, real quick show of hands. How many of you know what JSON Web Tokens are? Let's flip it up over then, because I can't tell. Do any of you not know what they are? It's a little difficult to tell. No? Okay, well then, okay. That's fine. I don't want to leave anyone out. This is gonna be awesome. Don't feel bad. So, basically, if you take JSON data, and you cryptographically sign it, you get a JSON Web Token. Okay, that's it. Now, a couple important things to know about this. They're cryptographically signed, which I'm going to explain in a second, but they're not fancy, and 99.99999% of the time, they're not encrypted, okay? That's really important. So if something's not encrypted, it means you can read it. If I give you a letter that I wrote, you can read that because it's not encrypted, right? Same thing with the JSON Web Token. It's a super common misconception, so remember that. Now, you might be wondering, what the hell is a cryptographic signature? It's an awesome, valid question. And cryptographic signatures, the way I like to explain them is like this. Let's say I handwrite you a letter, okay? And I sign my name at the bottom, and I mail it to you. When you get that letter, you're gonna look at the handwriting and say, hey, this like looks like Randall's handwriting. He signed it at the bottom. Therefore, I trust what the letter says was written by Randall. That's all a cryptographic signature is. It's a way to basically sign a blob of JSON information and basically prove that you're the one that wrote it. Does that make sense? Okay, cool. And that's what the signature is, right? So what do JWTs actually do? By the way, the common way to pronounce these is JWTs, not JWTs. So what do? They, like I said before, they just prove that some data was generated by the person that generated it. That's really all it is. If you go to the airport and you hand your ID to a TSA agent, what they're going to do is they look at the ID and they recognize this is a US government ID. And like, we trust the US government, therefore we believe the information on it. That's like the JSON data, right? So we trust that like, this is in fact Randall and he can like fly back home. That's how it works. Now, here's where things get fun, right? I'm assuming a lot of you are here because you want to learn about JSON Web Tokens, which is awesome. But what happens if you Google JSON Web Tokens? Well, basically, you get a lot of hype. People are super fucking excited about JWTs, like all over the place. So there's like a million blog posts online showing you like how to build your new Angular site with them, talking about like why they're the best thing in the world. There's a lot of like YouTube videos explaining like, here's the best way to like build your React application. And there's a lot of, you know, just screencasts and pretty much everything promoting them. You very rarely hear the other side of the story, okay? And this sort of annoys me because everyone is wrong. Like, I hate to say it, but everyone on the internet is, for the most part, completely wrong about JSON Web Tokens. And a lot of the time, I feel like I'm the one taking crazy pills because even in the industry I work in, a lot of people are like, you're crazy, like, that's not true, they're the best. And so part of the reason I'm here giving this talk is because I want to validate, for a selfish reason, that I'm not crazy. So what I'm going to do is, like, right now, a lot of you are like, well, this is crazy, they're like amazing, obviously. This guy's taught me shit, which is fine. So at the end of this talk, I want to do a show of hands and see if I can change your mind. So if I can, I'm going to feel a little less crazy. That would be awesome. Now, the real tragedy about JSON Web Tokens, right, is it isn't really so much that JSON Web Tokens are bad, which they are. It's more that people don't realize how amazing sessions are. Sessions are like the coolest shit ever, and everyone's sort of forgotten about it, and that's pretty sad. Now, before I can sort of like explain a lot of the stuff we need to talk about, I'm going to walk you through some terms, so we're on the same page. Now, if you have any questions about these, again, let me know, because you don't want to miss this. Now, the first thing you need to know about is what a stateless JWT is, okay? So when people are talking about using JWTs, 99% of the time they're talking about using them in the context of like logging a user in to a website or an API service or something like that. And so a stateless JWT is basically a JSON Web Token that contains all of a user's JSON information, or sorry, all of a user's information in JSON form encoded in this token. So for instance, if your website has users with like a username, an email address, a first name, a last name, a favorite color, a birthday, favorite car, those fields will be stored in this JSON blob that you can then read inside of this token. Makes sense, right? So if you pass that token to like an Angular app or something, you can then look at those fields and show on the page like, here's the user's first name, it's from within this token. Now, how does this work in reality? Let's take a quick flowchart here. So a user is logged into a website and has a token. And he makes a request to the website and says, hey, I really want to check out this page. So the website, what it's going to do is it's going to validate this token. And validating a token is something that's usually pretty fast to do, but basically, you check a few things. You check to see that the token is like has a valid signature. So remember that cryptographic signature before? You have to check to make sure that like it's not a forged signature or a fake signature or whatever. That's the first thing. The next thing it does is it checks to see like, is this token expired? Because tokens can have an expiration date on them. And so if a token is expired, you can't trust it anymore. And so you might reject this, right? Making sense? So then the website is going to it's going to look at this JSON data in the token, parse out all the key pieces of information, then it's going to render whatever page it was trying to show to the user and show it to the user. Pretty basic, everyone? Just some head nods? Cool. So next up, let's talk about what a stateful JWT is. This is the opposite of a stateless JWT. A stateful JWT is a JSON Web Token that basically only contains one thing, a user ID, also known as like a session ID or session token or whatever you might want to call it, okay? So if your user has an ID in your database of like 1, 2, 3, 4, 5, this would be the data you embed inside the token. Everyone good on that? Now, let me show you an example of how that works in practice. So the same user goes to log into this website, sends this token up to the server. The server is going to validate the token and extract the session ID number, okay? Then the website's going to talk to the database, usually like a Postgres database, maybe Mongo, whatever you're using, and say, hey, like who's this user whose user ID is 12345. The database is then going to pull the record out by doing the select statement or whatever you're using and say, oh, well, this is Randall, here's his user information. So it gets the user information, gives it back to the website, and the website then uses that information to render a page. Now, does anyone see anything different between these two scenarios? Hopefully that's a yes, right? One of them is talking to a database, right? And databases are slow. That sucks. Does everyone agree? Databases suck? Okay, awesome. Like all the DBAs are like pissed off in the back now and shit. That's okay. So we got that, right? So next up, let's talk about sessions. Because this is the thing not a lot of people talk about. And sessions are basically really simple. It's just that user ID, cryptographically signed. That's all it is, okay? Now, if we look at the way this works, it's going to work exactly the same as the stateful JWT, right? We're talking to the database and everything. The one difference is that we're not validating the token when we receive the initial request. Instead, we're just validating the ID itself because it's cryptographically signed. Does that make sense to everyone so far? Awesome. So it's pretty much the exact same flow. Next up, let's talk about cookies. So a lot of people I talk to think that cookies are like files, somehow, like a file-based protocol for storing information. It's actually a misconception. Cookies are basically an HTTP header, okay? So you can set it as like metadata about an HTTP request or an HTTP response. And all they contain is key value information. And the main thing you should know about cookies is they can store up to about 4 kilobytes of data, okay? Now, the way you create a cookie is, let's say you log into a website, right? When that website sends a response back to you, it will send this extra header called the set-cookie header along with the response. And what the browser does is it's going to look for this header, it's going to parse it out, and then it's going to say like, hey, define this variable called session and set the value equal to 12345 and store that in the browser. Then from that point on, the browser is going to get that variable and resend it to the server on every single request. So sessions and cookies are really just a mechanism for making browsers like remember important shit about your application. Now, if you want to create multiple cookies at the same time, you can do that using this syntax. You just throw a semicolon on there and sort of delimit them in that way. And then finally, when the browser sends this information back to the server, it's the exact same format, except the header name is called cookie. And that's it. Makes sense, right? Just resend the data that it just told you to store. So next up, let's talk about HTML5 local storage. So show of hands, how many of you are familiar with this? Okay, awesome. You guys are going to be so disappointed. I love this. People are going to be so upset. Basically, it's a JavaScript API that allows you to store data in the browser only through JavaScript, okay? And what's important to keep in mind here is cookies. Every time a browser makes a request to a server and a cookie's been set, the browser is going to resend that data to the server, right? With local storage, that's not the case. Local storage doesn't give two shits about what's happening, right? All it does is whatever you tell it to do in your JavaScript code running inside the browser, okay? Important distinction. I see a question? No? So now, this is the fun part for me, all right? I'm going to go through the myths about JSON Web Tokens. And the thing is, like, I really suck at counting, but I want to keep score somehow, so we need some help. So, the first myth I want to cover is that JSON Web Tokens are somehow easier to use than sessions. Now, raise your hand if you think this is true. No? So I don't have to convince you of anything then, basically. Okay, actually, how many of you came here tonight to learn how to use JSON Web Tokens in some way? Okay, cool. How many of you came here to learn how to use sessions in some way? Okay, actually, that's sort of surprising. All right. Well, anyways, basically, here's the raw facts, right? JSON Web Tokens, the very first draft of this specification, was basically at the very beginning of 2013. That's 4 years ago. No one basically ever used these at all or cared about them until mid-2014. That was the time that like they very first really came into existence. That's only 3 years ago. If you're using JSON Web Tokens today, if you're using like Node or Express or Angular or React or literally anything, you need a special library to parse these tokens. You have to actually know like, here's my cryptographic signature, here's my JSON Web Token library, here's the algorithms that I'm using, here's like all these different tools and things that I need to validate and like protect. So I'm just going to go out on a limb and say that's a little harder to use than sessions. And the reason why I'm saying that is because sessions have been built into every web framework since the 1990s, 1994 in particular. and they require 0 effort to use. So literally, every web framework you've ever used has supported sessions out of the box since it was created, most likely. If anyone knows of any things that don't support that, I'd be super surprised. Now, let's talk about score here, right? So again, I suck at counting. So what we're going to do is, can I pull this off? You can pull this off, right? Okay. We don't want to fuck it up too bad. Anyways, so I'm going to say JSON Web Tokens, and you guys say, you have to shout. This is pretty pathetic. Again, let's try this again. So JSON Web Tokens? 0. Okay, sessions? 1. Okay, this is starting to get all right now. Awesome. Now, let's unwind this. Hold on. I feel nervous standing so still up here. It's freaking me out. Anyways, next myth, right? JSON Web Tokens are more flexible than sessions, okay? Let's talk about this. So, what does a JSON Web Token basically look like? Just JSON data, right? Pretty simple. Everybody loves JSON. It's amazing. It's like super cool because there's like parentheses and like, you know, quotes and stuff. It's awesome. Now, here's the thing though. You can represent the same thing in session data form. This is the format that it looks like when it's sent over the wire. Now, it is identical. There's nothing different here except for the extra curly braces and quotes, okay? So it's slightly more efficient in terms of actual space. One sec. But you can accomplish the same thing. So, question.
But doesn't JSON store type information?
It does store type information. I'm strategically leaving that out. But here's the thing. Wait, here's the thing. I'm going to explain why later it doesn't matter. So let me get to that later.
So is that session information a string in the form of lines there? Or?
Yeah, so basically, so the question is the session information a string in the form of these few lines? The answer is sort of. So what's happening here is, as I mentioned before, sessions are basically just cookies, right? So when this is set, the browser is going to send, or the web server is going to send back a response that says set-cookie, session equals, and then it's going to say user ID equals 12345 colon, email equals art@degges.com colon, etc. So it's just a one long string. Make sense? Yeah. Question, yeah?
Did you have to hit store to get sessions?
Oh yeah, we talked about that earlier, but yes. And we're going to get there too, don't worry. Yeah. Oh, we're going to talk about that later too. But yes, if you're using cookies, you need to use special cookie flags, okay? And we can talk about that later. Now, some of you, I didn't hear this, I was actually surprised. A lot of you might be saying, this guy's a total noob, right? Because JSON Web Tokens are more flexible. They let you do really cool stuff like specify, like, you see this extra field here, the IAT? JSON Web Tokens contain a number of these claims, which are included by default on most implementations. This one, the IAT, stands for issued at. This is a timestamp of when the token was created. And that's sort of cool because you can see like, oh, like, when did I create this token? There's also an EXP time, which tells you when the token expires. And that lets you basically determine, like, does this token expire an hour from now, a day from now, a week from now? Like, when will this user get logged out automatically, basically, right? And all I have to say about that is that it just doesn't matter because sessions actually have the exact same thing and have had it forever. So you can specify expiration times in sessions. You can do all sorts of cool integrity check stuff, which I won't get into, but like, it basically supports the exact same important things between the two. Question, yes?
How are sessions different than cookies?
Oh, when I say sessions, I'm referring to cookie technology.
Okay.
So I'm just going to use them synonymously for now, okay? Yeah. So let's do this again. JWTs? 0. We can do better. Sessions? 0. Okay, cool. So next up, people say JWTs are more secure. This is a huge one because if you read any like blogs about building new websites, people say you have to use them. It's a new security thing, super important. So let's talk about this. So the good about JSON Web Tokens, right? They can be cryptographically signed. This is a huge security benefit. Just lets you verify that someone didn't just like forge some fake information and like log in as an admin on your site, right? They also can be encrypted. Now, 99% of you will never ever encrypt them. It's actually quite difficult to do so, but they can be encrypted, which is awesome. The bad news, however, the spec is complicated. I don't know how many of you read the JSON Web Token spec. It's actually one of a family of specs called the Jose family of specifications. This includes JSON Web Tokens, JSON Web Keys, JSON Web Signatures, JSON Web Encryption. There's quite a few different things that are basically built around them that they all need to operate in these different environments. And those are some of the most complicated specs in the entire security world, hands down. Also, in the last year alone, multiple major vulnerabilities have been found in pretty much every single large JSON Web Token library across pretty much every single web framework. So I don't think I'm out of line saying that like That's actually a problem. And finally, the biggest problem is that there's vastly different support for the spec across these different libraries. So if you go and look up how do I use JSON Web Tokens in Node, right? There's like 20 different JSON Web Token libraries. There's actually a website which aggregates all of them and compares the feature set between them, and it only compares really basic fields. Things like basic hashing algorithm support, encryption support, things like that. There's actually a ton of variables that go into these things, and implementations are almost never consistent, unfortunately. This is a much bigger problem if you're not building something just with JavaScript. If you ever work at a larger team or whatever, and you have like part of the code in JavaScript, part in Python, part in Java, whatever, it becomes literally a nightmare getting these things to interop with each other. Now, sessions, on the other hand, they are cryptographically designed too. They can also be encrypted. They've been around since '94. They've basically been completely battle tested. There's zero complexities in the spec. It's one of the simplest specifications ever. It's like key equals value, semicolon. No vulnerabilities forever that I've ever heard of, and identical library support everywhere. So I'm going to go ahead and give the points to sessions. Now, let's get better. JSON Web Tokens? 0. Sessions? 3. Okay, and question?
Why is it like my adware or my virus scanner identifies sessions as a security risk?
You have a virus scanner that identifies sessions as a security risk?
Basically, encourages me to delete any cookie that doesn't expire recently in some recent version.
So that's not a problem with sessions. That's actually a problem with a cookie being set for a too far in the future expiry date. I'm actually going to show you some stuff coming up soon that will put this into more perspective, okay?
All right, that's a good point.
So, another thing I've heard online, right, is that a lot of people have gotten used to this like EU law called the cookie consent law, which is basically where you visit a website and you see this little banner all over it. This is like, hey, if we are required by law to let you know we're using cookies to track you, like click here to say okay, basically, to continue browsing our site. And that's pretty fucking horrible, right? It's super annoying. So what a lot of developers do is they say, hey, I'm going to use JSON Web Tokens, and instead of storing information in cookies, I'm going to store it in local storage. And that's a really common like solution that people follow. The problem, however, is that they're all completely wrong. So if you read the law, it doesn't say anything about cookies at all. It's just named the cookie consent law. It has nothing to do with cookies. What the law states, basically, is that if you are tracking a user's behavior, like using Google Analytics or using like marketing tools, things like that, you're required to display this banner, even if you're tracking them using local storage. And if you're storing authentication information, it is excluded from this law completely. So it's just a super common myth that like this has anything to do with it. And because JSON Web Tokens are usually stored in local storage and not sessions, I'm going to go ahead and give the point to sessions. So let's do it again. JSON Web Tokens? 0. Sessions? 4. Okay, cool. Makes sense though, right? All right, it's not too bad. So next up, how many of you are familiar with CSRF, cross-site request forgery? Show of hands. Okay. The idea behind CSRF is basically, imagine you're logged into your banking website, right? And imagine some malicious attacker knows that you're logged into your banking website. So they send you an email and they're like, hey, click this cute dog image or whatever. And you go to click it because the link's broken, and it redirects you to your bank website, and it puts query strings into your URL. And it says like transfer like, you know, bank.com/transfer $100 million from my account, or from your account into my account. It's basically a social engineering attack where you trick a user into clicking a link to a site they're already logged into, okay? A lot of people online think that JSON Web Tokens solve this problem. So let's talk about that. Now, regardless of where you're storing your JSON Web Tokens, if you're storing them in a cookie, you are always going to be susceptible to CSRF. CSRF attacks have nothing to do with the type of authentication you're doing, just where the data is stored, okay? Now, if you're storing your tokens in local storage, you are exempting yourself from CSRF. And I won't get into the reasons why. You can Google it later. It's a little bit of a more in-depth conversation. However, you've opened yourself up to a much greater attack vector, which is XSS, cross-site scripting. How many of you know what this is? Okay, cool. So we need to dive into this because it's important. Now, CSRF is really trivial to fix. Ever since cookies were created, this has been a really well-known attack vector. Every single web framework in the whole world supports tools to prevent CSRF attacks. The same thing is not at all true about XSS. XSS is like a whole other level of being fucked, basically, because it's so difficult to prevent. Now, here's a question. How many of you have ever like copied JavaScript code into your site for Google Analytics? or for Marketo or any marketing tool, or for like Bootstrap or jQuery or React or Angular or Vue.js, whatever, right? Now, actually, looking at the show of hands, I see there's a lot of liars in the room because I know everyone has done this. So, got a lot of liars here tonight. That's okay. But basically, if you've ever done this, you are now susceptible to XSS attacks. The reason why, and let me explain this. Imagine your users are logged in with a token. The token is stored in local storage, right? Now, local storage can only be accessed via JavaScript code, right? Right? Okay, cool. Now, if you include some third-party JavaScript on your site, what happens is when the browser loads the page, it goes and downloads that code and then runs it. So what would happen if the person that's running that code modifies it to say, hey, send everything stored in the local storage to my private API? They can basically hijack all of your users' authentication information. It's super duper insecure. And you'd actually be really surprised. So I was going to tell this personal story, but since this is being recorded, I may not share all the details, right? But basically, a few months ago, I was doing some research, okay? And I noticed that this popular marketing tool that some of my coworkers were using was included on our website. And so I noticed that if I use the dig command, I can see that it's hosted via an Amazon S3 bucket. So it's hosted on Amazon. So I have the Amazon command line tools installed on my computer, so I figured, what the hell? Let me just see if I can access this folder. So I go and I list the folder, and I'm like, oh, well, they have the list permissions allowed, so I can view all the private files inside of this directory. First big mistake, right? Second big mistake, I was actually able to upload my own replacement version of the JavaScript code into the CDN. This happens way more than you guys would think, and this is a very large popular marketing tool, which went through disclosure already, but still, NDA. So basically, this is a very realistic scenario. The problem for most of us is if we're developing code and adding in very specific dependencies, we're probably a lot more knowledgeable. But at most companies, when you're building projects, you have marketing teams and people that are slightly less savvy, adding in tons of different trackers, ad service networks, stuff like that. And the risk there is super high for this to happen. So basically, don't just listen to me, listen to OWASP. They're the largest security think tank on the internet. They run a conference every year. They basically provide all the best practices for the entire industry. This is a direct quote from them. Don't store anything sensitive in local storage ever. So guess what? If you're using local storage to store tokens, you're doing it wrong, guaranteed. So if you take anything away from this talk, just take away, don't store things in local storage at the bare minimum, all right? Question, yeah?
So it seems like if you're, especially if you're in a single-page application and you have React, and cross-site scripting is still something that you're going to have to account for, even if you aren't using dots. If you're using cookie-based sessions, you still have to defend against cross-site scripting attacks because of all the examples. So wouldn't you argue that at least eliminating CSRF, however trivial it is to fix, you're eliminating an attack vector completely, and you're already going to have to deal with XSS, so it's sort of you're not really buying any additional security with cookies in that sense, because if they can run foreign JavaScript on your domain, they can make any API requests they want to with the cookies. They would give you authenticated.
That's an awesome question. You get one of these books for sure. But the answer is no. It's not safe. And the reason why is with cookies, there's no way to basically run JavaScript to steal the single most sensitive thing on your entire domain, which is the actual authentication data. So once an attacker has authentication data, they can talk to your website anytime they want and emulate your users super easily. And a lot of that is not easy to revoke, especially if you're using tokens that expire over the course of a day or a week or a month. A lot of websites tend to do that, so users don't have to constantly log in. It is a massive, massive security vulnerability to do that. Now, if you're only storing ad tracking code inside of local storage or things that are less sensitive, the risk is much, much, much less in general. So that's sort of my reasoning why I think that's still a better option. That's a great question. Okay, so again, let's count. All right, JSON Web Tokens 0. Sessions 5. All right, cool. You guys are getting better at counting. This is ABCs all over again. Now, another thing people say is JSON Web Tokens are better for cross-domain when you're working on authentication across multiple domains. This is a really great use case for tokens, honestly. Now, instead of me explaining why JSON Web Token for cross-domain sucks, instead of that, I'm going to show you how to do it the right way using cookies, okay? And the reason why is because we already sort of covered before that local storage, you should never use it. So if you're using it to do cross-domain, then you're already doing it wrong. So what I'm going to do is I'm going to teach you the right way to do it. Does that sound okay? Awesome. So let's say you're building a larger app. A great example of this is Heroku. If you've ever used them, they do it this way. They do an awesome job. So when you go to their website, www.heroku.com, it's just a static website, right? Just plain old marketing information, like here's our product, here's what it does. If you click login, what happens is you get redirected to a login domain. You end up at something like login.mywebsite.com, okay? Now, this is a different domain, so we need to do some login stuff. So what happens first is we show the user the new login page, right? The user fills out the login form, email, password, whatever, hits log me in. That information is then sent to the login app, right? What's going to happen there is it's going to check your email and password or whatever you have against the user database, and it's going to say, hey, you're logged in, I'm logging you in with a cookie now, and assign that cookie to the login.website.com subdomain. So they are now logged into that subdomain. The website is also going to generate a JSON web token that lasts for 10 seconds. So this token basically expires after 10 seconds. Does this sound good so far? Yeah. Now what happens is the login server is then going to redirect the user to the dashboard domain, or any other domain for that matter. And the important part here is in the query string, when they do the redirect, they're going to pass that 10-second token in the query string. Okay? So then the dashboard app is going to receive this request. It's going to parse out the query string. It's going to validate the token in the query string. And then once it's validated, it is going to generate another token, or another cookie, excuse me, for the user. So they're now logged in on both the login subdomain and the dashboard subdomain. Does that make sense so far? And then finally, once the user's logged in, they're going to see the dashboard page because it will finally be rendered. Now, the reason this is awesome, right, is because cookies are securely storing authentication information across as many subdomains as you want. This works on like www.google.com, www.facebook.com, whatever you want to do. They could be top-level domains, subdomains, doesn't matter. This is a really secure way to do this. Now, we're using tokens here, but not for authentication. Now, the important thing to note is we're using them as one-time use tokens, right? It's only being used once in the redirect, and has an extremely short lifetime. The token lasts for 10 seconds. And I'll talk about this more in a minute. But this is the proper way to do this. Now, because as I already mentioned, if you're using local storage to do this, it doesn't count, you're doing it wrong, right? The point goes to sessions, I'm sorry. So, JSON web tokens? 0. Sessions? 20. Okay. This guy sucks, come on. I'm joking. But let's cover the next one, all right? JSON web tokens work better on mobile. I've heard this a bunch. And actually, I'm just going to go ahead and say no, because it's not true. I don't know how else to explain it. I could show you like all the Android docs and iOS docs, but basically, they all support cookies out of the box like since day one. So I don't know what else to tell you. You're wrong. Now, JSON web tokens? 0. Sessions? 7. Cool. That one was my favorite. It was easy. All right, so next up. People say JSON web tokens are more efficient. And this is sort of an interesting one, right? But let's take a look at it. So I sort of hinted at this earlier. But JSON web tokens, if you compare the actual syntax of them to the cookie syntax, they are more verbose by design because JSON adds identifiers. Now, it's a mere number of bytes that this matters. So it's a stupid thing to compare. Here's where it gets interesting though. Almost everyone that uses JSON web tokens, they use stateless JSON web tokens, right? They don't use stateful JSON web tokens. The reason why is that when people are using them, they want to have the speed benefits of not needing to talk to a database server, right? That's like the main reason people like them. And so when you're using a stateless JSON web token, you're embedding all the user's information inside that JSON data. So what that means is the token is going to be much larger than an equivalent cookie-based token that only contains a single user ID. So there's a big size difference there. And now the other thing to keep in mind is whenever a user goes to view a protected page on your website, right? If they're using cookies, then whatever the authentication data is being sent to the website on every request. If they're using local storage, they need to use JavaScript to send this, but they still need to send it to authenticate themselves. And so what we're seeing here basically is there's roughly a 51 times size difference in the least case scenario between the two in terms of actual user bandwidth to talk to your website. So in my opinion, that matters. It might be a couple of kilobytes, it might be 1 kilobyte, it might be a little bit less, but it definitely matters. And one thing to think about is that when users are talking to your site, they're typically doing so over slower connections. If you're running your infrastructure in like Heroku or Amazon or Azure or wherever, you're on like a very high performance network with extremely a lot of bandwidth that can pass information back and forth over a network very quickly. So in my opinion, it makes more sense to optimize for your user's experience by not storing all this data on the client. And we can talk about that more afterwards. If you have specific questions, I can give you some guidance there, but just in general, they're much larger. So, JSON Web Tokens? 0. Sessions? 8. Okay. So next, JSON Web Tokens are easy to revoke. So how many of you know what revocation means? Okay. So basically what it means is like, imagine this, right? Imagine that you're storing your tokens in local storage. And someone does what I told you before and they get a copy of your token and they're able to like send requests to your website and imitate you. What happens is when you discover that, you want to say like, hey, this token should no longer be valid. This user should be logged out. And so you need to like revoke the token so it's no longer, you know, usable. So let me explain the way that like a lot of people approach this problem, right? Basically, the user talks to the website and says, hey, log me in. The website then logs them in and gives them a token and says that like the token might last for, let's say, like 1 hour, okay? So after an hour, the user will be automatically logged out. So shortly afterwards, because they're storing things in local storage, the user has their token hacked, right? And so on your website, you somehow detect this. Maybe they make a few fraudulent requests and you're like, this isn't right, let's shut this down, basically. So what they do on the website is they change that cryptographic signing key. That's the same thing as if I was writing letters to you and then I changed my name, right? Like you'd be like, oh, this letter says it's from like, you know, Troy or something now. That doesn't make sense. So you can't just change the signing key because then everyone who has this, my old letters, won't be able to figure out who they're from. And now at this point, you have a lot of sad users because basically when you do this, it will invalidate every token ever issued by your website. So every single user who has ever logged in with a valid token will now be logged out immediately. So changing the signing key is not a great way to do this. That's the first one. Question, yes?
This for JWT.
Well, let's talk about that after because it gets into like messy situations. But yes, you can use JSON Web Keys to do some other stuff around this. Now, you might also be saying, if you know a lot about this, you're a noob, there's better ways to invalidate using what's called a revocation list, okay? And basically the idea here is this. The user talks to the website, they're already logged in, let's say, and says, hey, show me this page. The website is then going to talk to a database and check that token against the database to say, hey, is this token still valid? Like, we need to know. Then the database will come back and say, yeah, it's invalid. We revoked it a minute ago. And then it'll tell the user, like, you can't view this page, basically, right? So that's how it works. Now, this actually works extremely, extremely well. But the only problem I have with it is like, what's up? Because you're basically back to negating the benefits of using tokens in the first place. The whole benefit of them is to keep them stateless, right? And not have to talk to a database. If you have to talk to a database, you might as well use normal sessions because they're smaller, they're faster, they're more efficient, they don't have this extra overhead. So it just doesn't make any sense. So you could do this, but it sucks, basically. So I'm giving the point to sessions again. So JSON Web Tokens, 0. Sessions, 9. All right, cool. Did that make sense, by the way? Everyone good?
Distributed revocation list.
A distributed revocation list?
Distributed revocation list.
Oh, we're going to talk about that. Don't worry. So that's actually this section right here, surprisingly. So a lot of people say JSON Web Tokens are easier to scale, right? This is a big one because scaling apps is like something that's generally hard to do for a lot of people, and so using something that can help you with that is like sort of cool. So let's compare. So on the good side, right? JSON Web Tokens can be validated locally without talking to a database. Obviously a big plus. This is where all the marketing hype comes in. The bad side, however, is that that only applies to stateless JWTs, right? Not stateful JWTs. And secondly, it requires more user bandwidth on every request, as I mentioned earlier. Now sessions, however, are sort of inverse, right? So on the good side of things, sessions do require a database lookup all the time, but that database doesn't have to be like a Mongo database or a Postgres database. It can be a caching server, right? Redis, Memcache, local memory. You can distribute this revocation list to all of your servers. So let's say you have 100,000 web servers. You could basically send a copy, like in a text file or a JSON message or whatever, to each one of them every time you revoke a token, and say, hey, just check in local memory against this list to see if someone's token has been invalidated. So you could do that. The bad side, however, is that sessions, of course, always require some sort of database or cache to retrieve the data, right? There's nothing embedded inside of them except for the ID, so you need an external store. Now, instead of me explaining, so I'm going to try to explain this. Instead of me explaining how to scale the JSON web token stuff better, because I think I just showed that like using the revocation list puts you back in the same spot, right? So instead of showing that, I'm going to show you the proper way to scale sessions really easily and really simply. Because this will hopefully help understand like it doesn't have to be something hard, and this is the same sort of thing you'd have to do with tokens regardless, except this will be a more efficient way of doing so. Fair enough? Cool. Now, let's say you have a site, and you have one web server, and you maybe have like 10,000 users. In this scenario, you don't really need to do anything complicated. A user visits your site and says, show me a page. You talk to the database and you say, hey, here's this user's ID. I want to find out who they are. The database gives the user information back to the website and finally shows it to the user. Pretty basic. If you have a site with even 10,000 users, 15, 20,000, you can get away with this no problem. Databases, even a single node database running on a very small server with 512 megs RAM, can handle many thousands of concurrent requests without breaking a sweat. Especially requests like this, where you're pulling a primary key out of a database that is indexed. Okay? Now, let's say you move on and your site grows, and you have 50,000, 100,000, 5 million, 10 million, 20 million, 50 million users. Okay? What do you do at this point? Well, again, it's actually relatively straightforward. So when these users all request pages, what you do is the same thing, except you replicate the databases and scale them horizontally. Now, pretty much every web framework has a tool to do this. Like in the Python world, there's like a bunch of tools that just automatically handle this for you. If you're running on Amazon nowadays, you can use Elasticache to just provision like multiple servers of Redis. You can provision clusters of these things very cheaply, very easily. They require 0 operations work to maintain it. And so you can easily distribute this information to caches, right? And so then you just send the data back. It's still super, super basic, super simple. This will get you to tens, even hundreds of millions of users potentially. Now, what happens when you get bigger than that? What do like massive, huge companies do? A lot of the time, they basically do something like this. They retain duplicate copies of their infrastructure in multiple geographic locations to basically segment things out to the region in which the user is making a request. So if a user in China goes to visit your website, they'll hit like these Beijing-based servers, and those servers will be segmented into little topographical regions within that geographic location. And each of those will have their own cluster of these caches that can then be used to store this information. So the same code will work on V1 of this as will work for tens, hundreds of millions of users. The code is actually no different. The only thing that's different is where are things located, how does the operations stuff work, stuff like that. But the concept is really the same basic concept. The software to do it is extremely minimal, and it doesn't require almost any extra effort on the effort of the developer, which is pretty cool. So yeah, so you can just do the same thing basically. So we're going to go ahead and get this point to sessions again. So JSON web tokens? 0. Sessions? 10. Okay. Now, the last thing, this isn't really a point, so to speak, but it is important because many people don't really understand the implications of this, right? If you're using JSON web tokens for your authentication data, you are by design using stale information about a person to speed something up, right? That's just what it comes down to. You're caching information in a blob of JSON information. So it's going to be outdated. Now, what a lot of people don't realize is like how much of a security risk this actually is. So if you're logged into a website and you have admin privileges, let's say, and then you take advantage of them, like you start deleting things. And so you as the website admin say, okay, I can tell Randall's deleting a bunch of stuff, revoke his permissions. If you are using JSON web token local validation, then what happens is when that user continues to delete things, your web server is just going to be like, sure, do whatever you want. You're still an admin. Your token hasn't expired yet, right? So by design, these things are designed to do this, okay? And so you really need to be careful. Like with authentication, you never, ever want to use stale information, ever. Like it's just not something you ever want to do. No matter what sort of user stuff you're logging in, it is misinformation that you should cache it. Same goes with authorization information. So authentication is like, is someone logged in, yes or no? Authorization information is like, what permissions does this user have? Can they like overwrite stuff? Can they delete stuff? Can they do this? Can they do that? It's a very common misconception in the entire web development world that like caching that stuff is okay. It is not. So again, we're dropping the point on sessions. JSON web tokens? 0. Sessions? 11. All right, now you're probably wondering how high is this going? Because we're at 11, this is gonna take all night. But that was actually the end. So let me explain some few things real quick. So first off, a lot of you are like, okay, maybe some of those things make sense. I sort of kind of get why they suck. So how should I actually use tokens then, right? And let me show you. There's 2 use cases where they're pretty valuable, all right? But again, they're not related to authentication, okay? So the first one is, let's say you download a movie, right? You buy a movie from, I don't know, redbox.com or whatever, and you go to download it. So you go to their website and you say, hey, I purchased this, I want to download it. The website says, okay, here's your download token. It generates a token. That token only lasts for 1 minute. What it then does is it redirects you to the download server where all the movies are stored. The user gets redirected to the download server. In the query string it says token equals blah, 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 whatever. The download server then is really simple. It's code-based. All it does is it validates the token and then sends the file to the user. It's super simple. And again, this isn't being used for authentication. It's being used as a temporary, short-term, one-time use token to validate that something happened that is true. That's all that it's used for. It's like a Boolean that you can trust over the internet. That's basically it. Now, the other use case where JSON web tokens can be really, really valuable is when you're doing something like resetting a user's password. This is like a very obvious use case for these things. So if the user says, hey, I want to reset my password, the website will say, okay, sure, I just emailed you a link, and that link has a query string that says token equals and a token. And that token will expire after, like, let's say 30 minutes. So then the user goes into their inbox, they click the link, they're redirected back to the website on the password reset page. The website validates the token, it says, hey, this is still true, and then it lets the user reset their password, and then they're all super happy, and they can go home. So this is a great use case for it because, again, not used for authentication data, temporary use, one-time use. Those are the key words here. So as long as you're using it for one of those purposes, you can actually use them successfully for a good purpose. Now, you may also be wondering, a fair question, right? Why are these things so goddamn popular? Like, if I'm talking shit about them, why are they so popular, right? And it's actually sort of my fault. But it's my fault and like everyone else in the security industry for the most part, okay? Particularly these companies, like that's Okta, or that's Stormpath, and that's Auth0. All of us actually have the same problem. And the problem is that the security industry is super fucking boring. No joke. Basically, security has not changed since like the 1990s for the most part. The only thing that's really changed is that computers have gotten way faster. And so we've made like incremental improvements to prevent attackers from like brute forcing our passwords, basically. That's really what it boils down to. Everything else in the security industry is literally the same. Very few advances have been made. And so, unfortunately, people like us, when new protocols come out, we get sort of like excited about it. And we're like, hey, this is pretty cool. How can we use this? How can we make it work? And unfortunately, back in mid-2014, a lot of us got together and said, oh, this is really cool. We got to write a blog post about it. And that blog post like blew up on Hacker News and blew up on Reddit. And then people started like sharing that on Twitter and like making YouTube videos about it and like teaching it in classes and courses and everywhere. And it's sort of literally just a runaway idea that hasn't really been captured yet. And the idea has been compounded, unfortunately, because of business reasons. And let me point out what I mean. If you go into a new incognito window and you Google JSON web token, let's actually count the links on the front page to see how many of them are actual technical information and how many of them are pieces of marketing information designed to get you to sign up for a service, okay? 1, 2, 3, 4, 5, 6, and 7. 7 out of the 10 links on Google's homepage, and many thereafter, are all basically just marketing pages which talk about JSON web tokens to drive you to sign up for some authentication service. That is 99% of the information out there. And unfortunately, because this stuff works, people keep making it, okay? So it's basically a marketing-driven technical phenomenon, okay? That is literally the reason why these things are so popular. And it's sort of unfortunate because it does a disservice to like all of us and the greater web for security in general. Now, my final call to action is this, right? Like, stop fucking using them, okay? Don't use it. It's great to use sessions. They're easier, they're faster, they're way simpler. You literally cannot mess them up in almost any way. So that would be my call to action. Thank you for having me. This is awesome. If you have any questions, I'm happy to answer them. If you want a book, you know, you can just come up and grab one. It's cool. Question, yeah?
So, what was the original motivation for the Jose spec and all that stuff?
What was the original motivation for it?
Yeah.
There's sort of a lot. I mean, it basically was related to the fact that the OAuth 2 protocol had recently taken off, and people were looking for a way to embed information about a user inside of the responses so you don't need to make an extra API request to get it. I could go into that like all day because there's a bunch of other reasons there, but that's the short of it. And today, a lot of big companies, they don't do this because they realize the mistake of doing this. And so things are slowly changing back in the other direction. But it's a good question. Yeah?
The Office we use, like Microsoft Office 365, authenticate most of our stuff through Microsoft Azure or whatever. That takes back a job. And we're using that to do most of our authentication, make sure Microsoft signed it, blah, 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 check the expiration dates. Are you saying that we should start storing users on our servers? Or, I mean, like...
So it depends on a few things. So like what he's saying is like when they're authenticating with Office 365 or Microsoft services, they get a job back. That's actually most likely because they're using the OpenID Connect protocol. JWTs are a standard that are in that protocol. So if anyone is using OpenID Connect, you are forced to use JWTs by default. That's like the 99% rule. Like pretty much everyone does that with OpenID Connect. Now the answer to your question is no. Don't bother rewriting that portion of your code base because it's simply not going to help you. And if Microsoft is going to force you to use OpenID Connect, then like there's not much you can do about it, right? Except not use Microsoft, which isn't, you know, it's not for me to say. But yeah. But it's a good one. Yeah.
What are some of the shortcomings that you think exist in the session approach? Not necessarily versus dots, but is there anything that could be improved on for a session?
So the question is there anything you can improve for sessions? And the answer is like, I don't think so. Because basically what it is, the idea is you take the simplest possible thing, a user ID, and you use that to grab a user's information. And a lot of the times, right, like we sort of tend to like invent like complex protocols for things when the simpler answer is more secure, faster, and just provides a lot of benefits. So in this case, I truly believe this is the right thing to do for everybody in every circumstance. But it's a great question. Yeah.
Can you use JWTs to store sessions?
Can you use JWTs to store sessions? So the question is, can you store a cookie's information inside of the JWT, right?
So if I'm using a connected TV or a mobile app that doesn't support cookies.
So if you're using a connected ID or a connected TV or mobile app or something like that that doesn't support it, if you're doing that, it's likely because that device is using OpenID Connect or some derivative of OAuth where the manufacturer is requiring a token in some way, I'm guessing. So I would say it's not worth trying to hack around it. Basically, if you have to use a token, you're stuck with it. You can't really get the benefits by like embedding something inside of it because you still have all the risk associated with the top level container.
And I'm writing an app for like mobile app.
Okay.
That uses OAuth too. I want to support them, but I want to communicate with.
So what I'd recommend you do, so if you're building an app using OAuth 2, the first thing is I wouldn't do that. Instead what I'd do is I'd use OpenID Connect with the implicit flow. Now if you're building a first-party app like for your website to directly consume, then you can use the OAuth 2 password grant to like sign people in directly. And if you do that with OAuth 2, there's no requirement to use JSON Web Tokens. So you can take advantage of that and do what like a lot of larger companies do. Instead of generating a token, you just generate a string ID for this client. And you keep a mapping of that in a database server, like in your backend somewhere. And you use that to populate information when requesting it. So it's not like a cookie per se, but it's like a makeshift cookie. It's the same exact thing.
How is that different than a JWT?
It's different because, well, all those reasons I just mentioned basically. Like the way that like they're implemented, the library support, the way that they're like basically interceptable in different ways. Another thing you can do to improve security on mobile apps in general is you can use this strategy called SSL certificate pinning. Basically the idea there is like, you know, a lot of mobile apps when you're using them, you can like man in the middle of them through your computer, intercept the traffic and decrypt it and see authentication data. If you use this strategy called SSL certificate pinning, you get a lot of benefits. What you do is you take your websites or your API, you get its public SSL certificate. You embed that certificate inside of your application code. And so when you connect to the server to make an API request or talk to it, instead of following the typical like SSL handshake that happens by default through like your HTTP library, you can basically say, don't trust my device's SSL certificate authority. Trust this one certificate that I have locally. If they're not the same, then reject the request. That means something's being intercepted. So you can use that as a strategy to simplify your life and sort of get rid of some of those fears, basically. Great question. Anyone else? Yeah.
So it's crazy if you've already mentioned this, but I guess I think the reasons I gather why you talk to me now is that one that you're trying to give ways to put meditate jobs. I kind of find it hard to believe that a whole 300 people, that those were the reasons why they put so much effort towards it. What about sessions is dangerous, or what? Is there anything that is a pitfall with using sessions that you should be aware of?
So the question is basically, right, like, if JWTs are so bad, why did a bunch of security people get together just because they were bored and promote these things, right? That's it's a great question. And the answer is it literally is that simple. Like, a lot of the people that actually promoted these are not security researchers, they're web developers. And so they have like a loose foot in the security industry. They're not like actual researchers. Like, a lot of this information can be found on, like, Kevin Burke's a really great security researcher who writes about this stuff. There's a lot of people online that actually post about this. The problem is they're not really embedded in web developer communities like I might be, or like you might be, or whatever. And so they're not really going around like publishing blog posts that go to like scotch.io and all the places where like Node people hang out. And so these things get sort of like overlooked, basically. And it really is that simple. Like, it's not like a huge cover-up or something like that. It's really just a basic explanation, which is that you can market it really well, and people like it, and so therefore you get a lot of users for your service and stuff like that. It's a very strong marketing push for companies, basically. Good question. Cool, I think, final question. All right.
One thing I've seen before is a JWT inside of the session code. Is there any reason why that should happen?
Yeah, so the question is, if you have a JWT inside of a session cookie, is that cool? The answer is, that's okay, actually. You could do that. The only reason is I wouldn't is because, like, you're basically doubly cryptographically signing something. You have to do twice the CPU work. And it's less efficient because it takes up more space. But if you really wanted to do that, you could, in fact, do that. Good question. All right, well, thank you, everyone. Feel free to grab some free stuff and hang out. I'll be around, so thank you.
Thanks for coming out, grab a book, grab more beers, some more pizza, grab a bunch of free stuff. Thank you.
I actually much prefer basic
Sure. Every time you have to get a
Well, not that. Basically, just send your API keys to whatever you're trying to execute against. Not for you. I can talk about that all day.
I would save that call.
With basic off, there's no automation. So let me explain this. So here, you can use the this is all like fully done. What happens is this is the every time they find they sort of just